Hi guys, welcome to this new video on Docker. And so in this video, I'll be talking about the Docker image anatomy. So what is a Docker image like? So yeah. So as you can see, a Docker build consists of a series of ordered build instructions. Each instruction in a Docker file roughly translates to an image layer. So let's see what is a Docker image that we have discussed before. So a Docker image consists of file systems. For example, let's say you have a Ubuntu file system. Then you add your app. So then you add Jenkins or anything Java app plus Tomcat or Jenkins anything. This whole thing is a image. So this is the root file system. This Ubuntu is the root file system. This Java is your application file system. And this is also your application file system. So you can see the image consists of file system. So it is a combination of different file systems. So here is the same thing is written. A Docker build consists of a series of ordered build instruction. Each instruction in a Docker file roughly translates to an image in a layer. So what does this mean? Let's say this is your Docker file that is from Ubuntu. Then you run this, then you run this, then you run this, then you run this, and then you run this. So this forms your base image. This is the Ubuntu. So every statement inside this Docker file corresponds to a layer in an image. So if I create an image out of this will contain 1, 2, 3, 4, 5, 6 layers. So let's say I will create let's say this I have created an image from this Docker file. So it will have a 1, 2, 3, 4, 5, 6 layers. So this image will have 1, 2, 3, 4, 5, 6. So you can see this is the Docker build, and this is a series of this is like 6. Each line corresponds to a layer. So each this line corresponds to this layer. This line corresponds to this layer. So this will create my image of this Docker file will create an image, and it will have 1, 2, 3, 4, 5, 6, 6 layers. So even Ubuntu, if you see, if this is Ubuntu, this is the run apt, this is the something run, this is copy, this is expose, this is entry point. So this Ubuntu can have its own images. Like this can have its own layer of images. Let's say it has X layer of images. So this Ubuntu can have its own this Ubuntu can have its own layer of images. So this Docker will have its own layer of images. So let's say it has X layer of images. So the total layer of images will be X plus 1, 2, 3, 4, 5, 5. So the final image that will be created using this Docker file will contain X, which is the number of layers in the Ubuntu image, then and the 5 and other 5 layers. So these were total layers. So Ubuntu is also an image. If you can this is an image on its own, and these are the changes on the file system. So every change in this base image will add a layer. So this is an image. This is an image. So you can create an image out of this layer, 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 image out of this layer. So every layer corresponds. You can make an image from every layer. So this is the base image. Ubuntu is the base image, and the commands we run, like the other commands in the Docker file, are just changes to the file system. So each change in the file system is a new layer, forms a new layer on top of it. So it forms a new layer on top. So you can also say like a Docker image is like a layer of file system, is made up of file systems layered on top of each other, because this is a file system. This layer is the file system, and this layer is change in the file system just below it. And this is the file system, that is the change, the change on the layer below it. So, and this is the same. This is the same. So you can say a Docker image is made up of file system layered on top of each other. You can also say like that. So basically the image or like the image or image layer or an image is an intermediate image. This is an intermediate image. This is an intermediate image. So every command like this, run, copy, and from, like in a Docker file, causes the previous image. Like this is the base image. So this causes this base image to change. So this run command. So this is this causes the base image to change. So it will create a new layer of its own. So this is the next layer. So next we have another run command. So this causes the previous image, like this image, to change, thus creating a new layer. This creates another new layer. So this creates another new layer, and this creates another new layer, and this creates another new layer. So the final Docker image we get will be this, which will consist of 6 layers. So like the concept of like layering was introduced like to save the build times, because if you see like if this I remove this copy statement, so the layers before this doesn't change. If I just remove this, the layers before this doesn't change. So the new image that will the new image I will do, it will use this part of the image, and then then run this three commands. I have removed this copy command, so in my new Docker file this command will be not there, like sorry, this command will be not there. So but the before that everything is same, you can see. So it will reuse this part of this image, and this is called layer caching. So this layers can be reused. So like if you can see the concept, this layers can be reused. Like so if you make a change, like if we make, like we made a change in this copy, we remove this copy, so Docker will rebuild only these two parts, like the above this, like above this run image, the lines which are next to this, the Docker will build the image from here. So we have seen we have like cached this layer, so you're using this layer, so the build time will be slow, like very slower, like the build time will be faster for that. So like just to reiterate, so what we did here was this from Ubuntu, this is the base, from the base of this layer, this is the base layer, and all these next statements make changes to this base image, intermediate image, or this image, Ubuntu image. So this creates a new layer of its own, like because this run command, like this run command changes the below image, which is the Ubuntu image. Like this causes this run command causes the previous image to change, just creating a new layer. So run command causes the previous image to change, so this creates a new layer. And this goes same with this thing, and this goes same with this thing, and this goes same with this thing. So what is the benefit? So as we discussed, if we remove this copy statement from here, you can see the previous layers are unchanged. So this part of these three layers can be reused. So this is known as layer caching. So anything above, anything like after this run statement, this has changed. So I have to rebuild this part only. So I have to run this expose and entry point. So I have like cached I have cached the layers, and I have reduced the build time. And the next thing is that like the layers are immutable. Like once they're created, you cannot read and write onto them. Like it is only read only. So that immutability like helps in the build times, because this base images can be shared by multiple. Like if two Docker files have the same, like you have a Docker file, another Docker file with the same from Ubuntu run, and this up till this we have the same statements. Like if you have Docker files which have same statements up till this, and only the statements change after this, then like these the images, like then they can set like they can use the same, like this can use the same, like same image, the same this three layers can be used by the two images. So this can save the Docker files. Like if I have a Docker file here, and if I have a Docker file here with the same state of statements from, this is also from Ubuntu, this is from Ubuntu, this is has also a run app, the changes are here only. So these two Docker files can like use the same set of, like these two can like use the same set of initial layers. So these initial layers can be used by the same like shared between these two images, and they only build the top parts. So this saves the disk space. And also one thing, all the layers inside the image are only read only. Like just a minute. Yeah, so these Docker layers, all these layers are read only. Like you cannot write onto these layers. So let's say you have an image. This is the image, and these are the layers of the image. Let's say this is the Ubuntu, this is Java, and this is Tomcat. And this like this every layer will have a UUID of its own. XYZ ABC PQR. So each layer of the images, like if you have this image, create this image, and this image has three layers, each layer will have its own UUID. So this these three images, when you run this image you have created, which is three layers, but when you will run it, this will be merged into a single layer or single image or layer. This and this is a copy. All these three are merged, and a new copy of this is created, and this is what is shared by all the containers. Not shared, a copy of this is shared. Like this copy, this image, like this merged image, not copied, this merged image will be copied, this image will be copied in each and every container, and this is called mounting of this image. So a single image is shared by multiple containers. So so let's say you have this image. Let's say this is your XYZ image, and you did docker run XYZ. So what happens? These three layers are merged first, and a merged layer is created, and then this layer is shared. It is copied to this container to run it. And let's say then you again did docker run XYZ. So again a new merged image will be created, a merged layer of this is the merged of like these three layers are merged, and a new layer is created, and this will be copied to this container and is mounted to this container. And if you again do docker run XYZ, again a merged, these three layers will be merged, and this is will be copied and mounted to the new, like to the new container. So this, so you can see a single image, like a single image is shared by multiple containers, you can say. So so what, let's see what are the layers, like what layers in practical way, and so it will be better to understand for us like how the layering in the practical works. As we have discussed before, like an image is like a is composed of various layers, and each layer corresponds to the line, it corresponds to the statements in a Docker file. So if we have from Ubuntu, this will create the base image, and the subsequent lines will be like a change in the file system, like a change in the file system. So each and every changes in the subsequent image will create a new layer. So the final, like a Docker file, the final the image that we get from the Docker file will be composed of various layers. So each layer is a change in the file system below it. So let's see the layers in in practical, like yeah. So I have my Docker here installed. So I have, and I'm logged into EC2 instance. Docker info, if I do, I have this Docker installed, and you can see if I do Docker version. So I have this Docker version installed. So currently I don't have any image. So currently I don't have any images like installed in my machine. So let's see Docker images. So you can see I don't have images. So, and also you have to see one directory. So this directory you can see var lib docker. So let's explore what is inside that. cd var lib. Yeah. Yeah, so we are inside the var lib docker. Let's see what's inside it. So we have this folders. So this image folder, you can see. So this image folder will contain the metadata about the image. This network will have the network objects of the containers and the images you run. This is the overlay too. This is the overlay file system that Docker uses. So we will go into deeper, we will discuss about the overlay file system, but let's get inside this overlay file system, overlay folder, overlay 2. Let's see what inside this. We have L, so cdl. We have nothing inside this, so we'll get out of this folder. Okay, so now let's pull an Ubuntu image. So Docker pull Ubuntu. So you can see I have pulled the image. So let's see what is inside this now. You can see I have this folder, this image. So let's get inside this so we can see we have downloaded this overlay. So this is the image which we have downloaded. So let's see what inside this image, what's inside this folder. So cd paste. We have diff and link inside this. And if I write Docker history Ubuntu, so you can see I've got this. I will again run this. Yeah. So you can see this is the image. This is the one which is here. This is the layer. So you can see this is the first layer, this is the second layer, and this is the third layer. And third layer is 78 MB. You can see. So this is the image which we have got here. This one. So this is the layer, not the image. This is the layer of the image. And the other layers are 0 byte because these are the metadata, contains the metadata about this, contains the metadata about the layer. So this total is the image, and this is just the the one of the layers. So if I copy this, if I go to this, So if you see, just a minute. This one is like the layer, which is also known as data layer. You can also say this data layer, because or you can say this is the layer, because this has the only like 7.78.1 MB. So this is the biggest, like the most size. So these are all the layers, and this is this 1 2 3 4 5 6. You have 6 layers which constitutes of this image which you have built. So the 0 bytes are for metadata. So what we can do is like go here, clear the screen, and we can write cd, get out of this folder. You can see this layer, this is the layer ls. If I do, this is one of the layers, and the other layers and the other layers we just saw, which are of 0 bytes, are in the another directory. So those will be in this directory, this image directory, because it's the metadata. So let's go back to this overlay 2. So yeah, so I have this image, and let's see what's the size of this layer. To see size of the layer, we can use h. No, I have to do dukh, I guess. I did something wrong. Just clear the screen. Yeah, so you can see this contains 84 MB. So this is the one of the layers of the Ubuntu image. So what we can do is like we can get into this image as we did cd into this layer. I mean, not image. Yeah, this is cd. So this is diff and link. So the data will be this. And one thing to remember, like we just like pulled the image. We haven't started any container, and you can also inspect like inspect this image. That's this Ubuntu image. So Docker images. If I do, and using the image ID, if we inspect this image ID, what we'll get? Let's see. Docker specip. One thing to remember, I haven't started any container. So what we are inspecting is only the image, and what we saw in the overlay 2 is also the image, one of the layers of this Ubuntu image. So you can see directory. Yeah, so you can see it has only one layer, right? One layer, and that one layer is the data layer, in which we are in. Like this is the data layer. If I get out of this folder and do ls, this is the layer or data layer which we just saw after inspecting this Docker image. So this Docker image contains only one data layer, this layer, and you can see this layer is here. So now let's see what will happen if we run this Docker. Sorry, this Ubuntu image. What will be there? Let's see. Docker create name Surya Docker, and the image ID was what? This. So I have created a container out of this image, Ubuntu image. Now let's see what is inside this. Yeah, you can see previously we were inside this folder C7, this one, and now another folder has been created. Another folder has been created, which is this. This is created because that we have discussed previously that all the layers inside an image will be merged to a new layer. So this is that layer. This is this is the read and write layer. So this is the additional layer. So this layer is created because all these layers which we'll have inside this layers array will be merged into a new layer. So that layer is this. So this layer is a combination of all the layers. So this is created using like merging, after merging all the layers that we have in the image. So let's see what is inside this. So if we go inside this, so you can see we have diff, link, lower, and work. So what is this inside diff? This diff will contain all the changes that we will do inside the container after the container has been created. We haven't started the container, we just created the container. So let's start the container. So if we start the container, docker psa docker start, and this is the container id. So if I paste it here, and I have to do it like, I have to run it, because it will not run because it has a bin bash thing. So docker run itt ubuntu. So a new container is created because I have used run. So let's go inside this folder, cd ls. So you can see I have another merged layer. So like another, since I created another container, all the layers of the image are merged. So what I'm telling, no. So what I'm telling is, I have this image, draw. I have this image here, which contains layers. Let's say this is one layer. These are the two layers. This is layer 1, and this is layer 2. And in this, like in this image, like Ubuntu image, we have only one. So we have seen we have only one when we pulled the image from the repository. So now while we are running, so let's say we are going to run this image, and what you do is like, what happened to this thing? Yeah. So when you do docker run your image, these two layers will be merged to a single layer. And this layer will be attached to the container. And let's say this is your container. This layer will get attached to the container. Now again, let's say you run docker run your image. This is the first time you run, and again you run this same thing. And again you run the same thing. So what we'll do, this will again get merged to a single layer. These two layers of your image will get merged to a single layer and will get attached to the new container, which you have run using this command. So if you do this like docker run multiple times, so multiple times these two layers will be merged, and a new layer will be created, and it will be attached to the container. So you can see, so here I have created two containers, you can see. So because of the two containers, and I have the image, only one layer of the Ubuntu image, so I have three. So previously I have created, so docker psa. So you can see this one is running, and this one has exited. So let's delete this. So remove the, let's say, yeah. So you can see this one is the like this. So this layer is from the image which we have put, and this layer is the merged one. So let's go inside this cd paste. Yeah, you can see this is the merged one. So this merged contains all the, as you can see, this one is the merged image, merged layer. So all the layers has been merged to this one. So we are inside this folder, this merged folder, and this will contain all the all the layers of the image from which it has been merged. So let's go to the merged directory, cd, and if we go into ls, you can see this contains all the file system. So as we have discussed, like this this base image was Ubuntu, and then we like we have a Java application, then we have then we have our application file system. So Ubuntu file system, after that we have the our application file system, then we have another application file system. So this is the top view of the file system. Like this is the overlay file system which we have used. So anything like if we like now if we touch or do anything inside this container, let's get out of this here. Yeah, and ls. Yeah, so now if I write anything, let's say docker psa. Now if I want to write anything inside a folder, opt folder inside this container, so what do I do? I will use the docker exec command, then the container id. What will happen? Control C. Yeah, so docker exec this container. I want to run my command inside this container, so I'll copy this container id, paste this here, and what I want to run, touch inside the opt. What I want to do, abc.txt. Yeah, so you can see, and let's see what if it is created or not. Now if I do ls, you can see abc.txt has been created. So now if I do this ls, you can see inside the diff folder, inside the merge folder, we will be able to see the abc.txt. So let's get inside the diff folder, ls. You can see the opt ls. You can see the abc.txt. I will get out of this ls. Are we recording? Yeah. We will do ls. We'll get into the merge directory. We'll do ls. We'll go to cd opt. We'll do ls. You can see abc.txt is there. So when we are writing this diff command, so you know we have a diff command, diff, and this container id is what? This is the container id. After this docker diff, I guess. Yeah, you can see it just returns the diff directory of this layer of this image, which is the Ubuntu image, which is with the container is running. So this is the merged image. Inside this merged folder, we have this diff directory. So it returns this. So let's say ls, get out of this folder. So now let's say I want to stop this container. Docker psa. So docker stop. I want to stop this container. So paste. Yeah, so let's say it is running or not. Because it has exited, and let's see what is inside this folder. So which folder are we in? We are in the merged folder, which is created when we create a Docker container. So what it does, it just merges all the layers in the image and creates a new layer, which gets mounted to the container, and this is the layer which is right now mounted to the container. But the container is not running, so let's get ls. So you can see that merged folder has gone. So what did just happen here? So the merged folder, since the container is not running, the merged folder is like removed from this, from this directory, and all. And but you say, but you have done some work inside the container. So the work is inside this diff folder. Let's go it inside this diff folder. Since we have written at abc.txt inside the folder, you can see it is still there. So now if you start the container, the file system, the changes which we did to the container will be copied from this diff folder to the merge folder. So let's say let's start. Let's check it is there or not. You can see that abc.txt is there. So I will get out. The merge folder is gone. Let's start this container again. You can see the merge folder came back. And if I go inside the merge folder, cd opt, you can see the abc.txt is there. So when I am stopping the container, this merge folder is deleted to save the space. And since this merge, this is only read only, you can say. So when we are starting the container again, like not starting, yeah, when we are starting the container again, it is just what it is doing. It is just getting that creating like it is merging all the layers from that image, the Ubuntu image, and then it is creating the merge folder, and it is copying all the data which we have all the data which we have maybe created since we started the container, and it is copying it into the merge folder. So this is the design, like how it works when you start and stop a container, and all the layers and layers of the file system, etc. So just to reiterate what we did, so just to reiterate what we did, we had a Docker image. Docker images. Yeah. So this is the image we have. So now if we inspect this image has been pulled from the Docker repository. Now if we inspect this image, we can see we have only one layer in this image. So now when we are running this image, like we are Docker run this image, then since we have only one layer, it will be merged to another one layer. But if I had multiple layers in this layers array, all of them will be merged to a new layer, and that layer will be mounted to the container. Like if I have multiple layers inside these layers, like if we consider Jenkins, let's pull Jenkins, Docker pull Jenkins / Jenkins. What did just happen? Achha, I made a mistake here. Let the pull get completed. Now if I do Docker images, you see I have this Jenkins image. So let's inspect this image. You can see we have multiple images here, and this we also can verify if we go to this overlay thing. See, you have like 7 images we have downloaded. These are all the layers, not the Jenkins image. These are all the layers of the Jenkins image. So now if I run this, like if I do Docker run Jenkins, all these images, sorry, all these layers will be merged to a new layer, and that new layer will get mounted to the container. So this is how this thing works, like layering and this thing works. So thanks for watching the video, and I will see you in my next video.